Welcome to Code Report. I'm your host, Connor Hoekstra. I apologize for posting this a couple days late, but as I mentioned in the last Sunday weekly episode, I was out of the country for the last couple days, and so that's why I'm posting this now. And you also might have noticed that the intro music for this video has been different than the first 36 episodes. The music track that I was using, I'm not sure if any of you recognized it, but it was the soundtrack to one of my favorite television shows when I was a kid, and that was Numbers. But unfortunately, or fortunately, I guess, because my channel is getting noticed a bit more, it was claimed copyright by one of the music labels, I guess, that owns this track. So that's not really that unfortunate because I'm not a YouTube partner right now and I don't make any money off of this. But in the future, I hope to be, so I have to use a different soundtrack from now on. So I randomly chose one from the YouTube audio library, which you can use any of those songs without worrying about copyright infringement. But what I'm going to do is I'm going to leave a couple links to the song that I chose and then one other song that I thought I liked. So I will post comments with links to those songs, and if you like them, you can sort of upvote them by hitting the like button, but anyone is more than welcome to post a link to a copyright infringement free song that they think sounds good. And I'll be the one that decides at the end of the day, but if overwhelmingly, the subscribers or the viewers of that video like one song over all the others, I will choose that song. So if you know a song or you feel like going to the YouTube audio library and sifting through some to find one that you like, feel free to post a link to that audio track, and then others can listen and you guys can vote for your favorite. That being said, let's take a look at the contest that happened last week. So last week we had a few contests, starting with the Hour Rank contest from HackerRank, which was on Tuesday. We had two contests from Codeforces, round 513 and round 514. 14 was announced sort of halfway through the week. We also had the start of the Code Chef Long Challenge on Friday morning. We also had from Hacker Earth the October Easy contest on Friday as well. And finishing off the week, we had, of course, the weekly LeetCode contest number 105. Taking a look at the top 10 leaderboards, from as far as I can tell, there was only one individual to place on multiple top 10 leaderboards, and that was Yui, who placed third in the HackerRank contest and seventh in the LeetCode contest. But we had a number of other familiar names. Tourist, aka Gennady, finished in first place for the HackerRank contest, followed by Igor in second, Talaria in fourth, and I Love Tanya in fifth. KMJP also finished in sixth. Then taking a look at the round 513 Codeforces contest, we had Scott Wu finishing in first, and then some other big names down the list: Fade Ice in fifth and B Mary in sixth. Taking a look at our updated overall Codeforces leaderboard, we didn't have any changes in the top two spots, but due to FJZZQ 2002's finish in the 513 contest, that individual jumped up into third. Petra jumped one spot to fourth. Umnik dropped down to 8th from 4th. LHIC jumped 2 spots from 7th to 5th. Kongling Dan Pai Sheng 3K5 jumped into the top 10 leaderboard for the first time due to the Lyft Codeforces contest that happened over the weekend. KO Osaga dropped from 6th to 7th. Bank dropped from 8th to 9th, and Swissstock dropped from 9th to 10th. In today's video, we're going to be covering an alternative to a solution that we covered in a previous video for the HackerRank Hour Rank 30 Problem 1 problem entitled Video Conference. So if you haven't seen the previous video, I will link to it up here. I would definitely recommend going and watching that so that you understand the initial solution and the problem, as I'm only going to briefly go over the problem statement and the solution that I previously covered. So the problem states, basically, the summary of it is that we're given a list of names and we want to show a prefix of that name that hasn't shown up previously. So if the three names we're given are Alvin, Alice, and Alvin, we're going to show A for the first name Alvin because there are no prefixes at that point. Then for the second name Alice, we're going to show ALI because the prefixes A and AL occurred in Alvin, but ALI didn't occur. And then for the third name, Alvin, there's a sort of extra detail to the problem that says if you've seen the name before, print the full name plus the number of times that it's been seen at this point. So we're going to show Alvin 2 because it's the second time we're seeing Alvin. So that's the basic summary of the problem, and the solution, or the general solution that I showed in the previous video, was that you can basically use a hash map of strings to store all the prefixes, a hash set of strings to store all the viewed prefixes up till the current point in time, and then also a hash map that stored the occurrences of full names. And so using those two, you could sort of determine the total way that you want to view your names. But I had a number of comments on that video. The first one was from Arup. I apologize if I pronounced that wrong. And this individual pointed out that there's a better way to solve this problem, which provides better complexity. Doing a search or insert on a map consumes O log of the current size of the map in the general case, but if we use the try data structure, we could achieve better complexity. And then I sort of went back and forth with Arup, and I noted that for the solution that was provided, it was rather lengthy, and that in a competitive coding situation, the faster you can implement a solution, the better, even if the time complexity isn't as good. But there's something I'd like to note, that the time complexity of both of the solutions, that the one that he's providing and the one, or he or she is providing, versus the one that I provided, they actually have the same time complexity. However, using a try is definitely the better approach because it provides, when using a try, the space complexity is much, much better. When you start to have duplicate prefixes, a try isn't going to store those duplicates over and over and over again. And even if you don't have duplicates, storing the prefixes individually, you're going to end up with sort of a quadratic space complexity for each string that you add. So a try is better, but my point here was that to code the full solution that was provided, this was much longer than the solution that I had provided. And if you have a solution that's, space-wise or time-wise complexity not as efficient, but it still meets the requirements, you should opt for the one that's easier and faster to code. That being said, there was another comment that was posted by Chen-Xing Li, who also pointed out that this is a perfect scenario to use the try data structure, etc., and provided an implementation that was roughly 10 lines long in Python. And this surprised me. And at this point, I said, this is awesome. I'm gonna, show this in the next Sunday weekly episode, and decided to basically recover an alternative solution to this problem. So let's jump into what a try is. So here we have an example. We've got 5 names. They all start with J, and they're Jim, Jack, Jim, Joel, and Joe. And basically the way that a try works is it's a tree where each node has a number of, pointers to other characters. There's sort of multiple implementations. The first one that we saw from Arup was node-based. The second one we saw from Chen-Xing was hash map or dictionary-based. But the basic idea is that if we start with our first name, Jim, we're going to store a node, and each node is going to contain a character. And then this is going to contain a pointer to another node, which will have another character, so the I, and so on and so forth. And when you get to the end of the string or the name, you want to have a way to denote that this is the end. And so basically, whenever you want to search, at this point, this is what our try looks like. If you want to search if Jim exists in our try already, we can simply look through by character, and at this point, when we get to the end, we know that exists in our try. So here we're also going to be checking prefixes. So basically, anytime we are inserting nodes, we know that, okay, this node doesn't exist, and then we can print something. So for Jim, because there was no prefixes, we're going to end up outputting J. But if we move to Jack, at this point, the J node already exists, so we're not going to do anything there. And when we go to insert the A, this is a new node. So at this point, we know, okay, this prefix hasn't been seen before. Let's output JA. And then we're going to continue character by character to add nodes to our try. So we end up with JACK, and then we're going to denote that, this is the end of our name. And so we're going to use the way that we denote it is a little bit different in the Python and C++ solutions, but basically this is how we can determine whether or not we want to output, the full name with a number. If, our flag or our indicator is set here at the end of a name. So if we move on to our third name, back to Jim, basically all of the nodes here are inserted. So we're going to get down to the end here, and basically at this point, implicitly where we have the K and where we have the M, we have a sort of a flag that's set to 1. And so we can increment this to 2 in this case and then output Jim 2. Then we move to our fourth name, Joel. So in this case, once again, the J node already exists, but the O, the E, and the L don't. So we'll end up adding those nodes. And the first node that we added was O, that didn't exist. So we're going to output JO. So then we come down, insert an E node and an L node, and then we turn this to sort of the end of the name. And last but not least, our final name is Joe. And note that though this was sort of a corner case that we covered in the previous video, that when your name is a substring of a previous name, but that name hasn't been seen before, we want to make sure that we output the valid full name, even though you might think, oh, we want to, because we're already seeing this substring, we might want to output, Joe 2. That's not the case because the name hasn't been seen before. So we'll come to our J node, our O node, and our E node, but because it's not a red node, it's not indicated as being a name that's been seen before, we'll just change our E to be the end of the word here, and then we'll output Joe. So that's basically visually how a try works. You can have node-based implementations, you can have hash map-based implementations, but the idea being is that any common substrings are shared, and that you have these sort of sentinel nodes that indicate the end of words. So this is a very, very efficient way to implement a dictionary of words, not a dictionary in the Python sense of a hash map, but the dictionary that you flip through to see what words exist in a language. A lot of times you can use a try to store all of these words, and it's a lot more space efficient than individually storing every single word in like a hash set or something like that. So hopefully this makes sense. Let's take a look at the code for these problems, and we're going to start with the Python solution because that's what motivated me wanting to make this alternative solution to this problem. So here is the Python solution. At the top here, we just have our function solve that takes a list of names. Here we're declaring our try to be a hash map or a dictionary, and we're declaring res to be a list, which we're going to return at the end. It's going to be a list of the prefixes / names that we want to output. And then we have our for loop for each name and names. We're going to set a local node to be equal to the try. And then we have this Boolean printed, which is set to be equal to false. So basically, when we've added this to the res list, we want to turn this to true. And so then we have another for loop that says for I, x in enumerate name. So basically what this means is I is going to start at 1 and then increment each time. So it'll be 1, 2, 3, and then x is going to be the character in name. And so then it's basically checking, is the current character that we're at, does it exist in our current node, so in our current dictionary? If it doesn't, and we haven't already printed a prefix for our current name, then add this prefix using the I that we got from the enumerate to get the prefix and append this to our list. And then at that point, so actually this is a mistake here. This should be indented. Set printed to be true. And after we've done this, we want to initialize a new node. And we do that by setting the value that we get from our key, which is our character X, and then we just use default dict to initialize a new hash map. And then basically once we've gotten through this sort of piece of code here, we want to set our current node to be equal to that new hash map that we initialized. And if we didn't initialize it, we just want to get the one that's already been set up. So basically what this does is for each character, we're getting the next step down. So when we had Jim and we went to J, then to I, then to M, this is the line here that switches you from J to I and I to M. And at the end of the name, we're basically setting a string in our hash map to be equal to 1 plus what the previous value was. And so this is basically the flag that indicates that the node is red, or that the node represents the end of a name. And so at the very end of this, once we've done this plus equals 1 to our count, we check once again if we haven't printed the name at this point, or a better name for this Boolean would be added. If we haven't added this or appended this to our list yet, then we want to do so at this point. Basically, that's the case where, when we're trying to output Jim for the second time or Joe for the first time, we never saw a prefix that wasn't the full name at that point. So at this point, printed would still be set to false. And so we just call this piece of line to append the number to the end of the name. So that's the Python solution. This was very nifty. I would try to understand this. If it's not, work through this and then try and code it yourself, because I think this is a really, really good implementation. If you were in a interview and you got asked a problem like this, implementing a try like this, I think is a very neat way to do this. So let's take a look now at the C++ solution that was motivated by this Python solution. And note that Python is an interpreted language, so here we don't actually need to explicitly declare the types in our declaration of our dictionary, or what's known as a unordered map in C++. But C++ is not an interpreted language, it's a compiled language, which means that we do need to explicitly declare those types, which means we have to sort of approach it slightly differently. So here is our C++ solution, and as I mentioned, we need to do something slightly different. We can't just, initialize our try to be a hash map where we don't declare what the types of the key and value are. So the way to get around this is just to declare a small struct which contains a hash map, and the key is going to be a character, and then the value is going to be a pointer to the type try that we are implementing here. So this is sort of it's basically implementing the recursive hash map, that was enabled due to the fact that Python is a interpreted language. So we declare this struct, and then we also have this count equals 0, which we're going to use to represent the red state of our node, or the end of a name or a string. And note that this is not a very good way at all to implement a try. It involves using naked news, which you should basically never do according to best practices, but I'll cover that at the end. I consulted with Dennis, and he provided a really nice implementation of a try, which I'll show after this. So note, this is specifically something you only want to do in the competitive coding situation. So at the top of our solve function, we are creating a try t here, and then we're also declaring a vector of strings res that we're going to return at the end, similar to the list that we returned in Python. Then we have our range-based for loop for each name and names. We're setting a local pointer node to be equal to our t currently, and then setting up a Boolean as well that is called added more appropriately in this solution, initializing that to be equal to false, and then also setting up a string to be called p, which is going to be our prefix, and initializing it to be blank at first. Then we're going to loop through each character in our name, do a plus equals of the current character to our p to get the current prefix, and then we're going to check in our code, or in our node that we're currently looking at, does this character exist? If it doesn't, and then we're going to come in here, and on the second line, we're going to basically initialize that new node. But we're first going to check if it hasn't been added, then we want to push back the prefix and then set added to true so that we don't continue to do this. Once we've done this, we then basically want to reset our node pointer to be the current character hash map. and continue to do this similarly like we did in the Python solution. And then at the very end of this inner for loop, we do a post increment on our count value, which will then keep track of sort of the number of times we've seen this name. And then we have a very, very similar call to the end of the Python solution where we check if at this point we still haven't added our prefix or our name, then we want to do so by adding the number of times we've seen the name so far. And at the end of this, we just return our vector of strings. So the time complexity of this solution is, as I mentioned before, the same as it was for the first solution that I covered involving the hash set, and it's just big O of n, where n is the number of names, times s, which is the length of our names. And last but not least, as I mentioned before, this is not a very good way to implement a try, but it is an efficient way to implement a try in terms of the number of characters you have to type. But a much better way, and using more sort of modern techniques and best practices, is the following. So this was implemented by Dennis, the C++ code reviewer of the channel, and this is really, really great. So I'm going to leave a link to this in the description down below. I would definitely try to understand this. You know, it's not using a struct, it's using a class. So you've got your access qualifiers here. You know, most of this stuff's private, and then you only have a couple public methods, insert. And, you know, this is something that you would be much more likely to see in production code versus the competitive coding solution. And that's always something to keep in mind, is that when you are coding for these competitive coding contests, you know, you want to make sure that you are keeping in mind that a lot of the things you do in competitive coding does not translate to best practices in production code. So as long as you keep that in mind, you should be good to go. So taking a look at the contest happening next week, as I'm recording this and posting this late Tuesday night, tomorrow morning is our first contest, which is from Topcoder SRM 738, or I believe it's actually 739, that starts at 8 a.m. And then on Thursday, Friday, and Sunday, we have 3 contests from Code Forces: Educational 52 on Thursday, and Round 515 and 516 on Friday and Sunday, respectively. On Saturday morning, we have from Hacker Earth the Hour Storm number 4 contest, which is only an hour long. And of course, we have the weekly Leak Code contest number 106 on Saturday evening. And don't forget that throughout this week, we also have from Code Chef the October long challenge, which is going to go till about Sunday, Monday, depending on your time zone. As always, if you enjoyed this video and found it helpful, hit that like button. If you want to see more, make sure to hit that subscribe button. You can follow me on Twitter for reminders 30 minutes before contests start, and you can find all of the code shown in my videos on my GitHub page. Thanks for watching, and I'll see you in the next video.